Hello again, everybody. This is Mr. Hoy. In this example, we're going to be constructing a rectangle. We'll be providing you with the area and the side measures. Now, the side measures in this case will be represented as expressions. So we'll have a side measure of 6x plus 7. We'll have another side measure of x plus 3. And we'll be using those expressions and that given area to solve for x. What I first recommend here is drawing the actual rectangle, maybe putting 10 in the middle to remind yourself you're talking about area and not perimeter. A lot of students get those confused. The area of a rectangle is the length times the width. Now the sides measure 6x plus 7 and x plus 3. It doesn't really matter which is the length and which is the width. So what I would do with the image is you can put 6x plus 7 here and x plus 3 there, or you can have those reversed. It really doesn't matter a whole lot. And we're going to take our formula, our area equals length times width, and substitute our values. So put the area there. I will put 6x plus 7 here, and I will put x plus 3 there. You just want to set up the equation so that you can sort of take it from a more abstract geometry problem to an algebra problem that's a little bit more straightforward. So when looking at this question in particular, make sure that you've got both equations, or both expressions set up on one side, representing the length and the width, and you have the area on the other side. So I'm going to keep going down this equation. We would have 10 equals, now we want to use the FOIL method to simplify this side. 6x times x is 6x squared. 6x times 3 is 18x. 7 times x is 7x. And 7 times 3 is positive 21. We can simplify this one a little bit further by combining those middle terms and making that 25x. Now, what I want to do here with this positive 21 at the end is I want to try to solve this by shifting this 10 or subtracting this 10 from both sides. To get 0 equals 6x squared plus 25x plus 11. Now at this point we want to do our AC method. That means to multiply a by c. So we'll multiply our 6 by our 11 to get 66. And we want to look for factors of 66 that add up to 25. Please be careful in this step. If you mess up the factors, the rest of the question will also be wrong. The two factors you should find here are positive 3 and positive 22. Just as we've done in previous lessons, you then want to take those factors and use those as your two middle terms now instead of your 25x. I'm going to shift the problem this direction over here. We'll have 0 equals 6x squared plus 3x plus 22x, and finally plus 11. We can factor this by grouping. The first two terms, we can factor out a 3x, leaving us with x plus 1. The last two terms, we can factor out a positive 11, leaving us again, sorry, this was a 2x plus 1, with 2x plus 1 here. Sorry, I made a mistake. First, when factoring out the 3x, 6x squared divided by 3x would be a 2x, so this would be 2x plus 1. We can go further down with this question. We'll have 2x plus 1 and 3x plus 11. So now, just like we would in last week's unit, we're going to take the 2x plus 1 and solve that individually. 0 equals 2x plus 1. Negative 1 equals 2x. And x equals negative 1/2. We'll do the same thing with the 3x plus 11. That would mean 3x equals negative 11, and x equals negative 11 thirds. You could also view that as x equals negative 3 2/3. Now what you want to do at that point, and this is the more confusing part of the question, is we want to take those answers and try to substitute those back in to see if one of these two answers is not possible. What I mean by that is, will one of these two answers, when substituted back into the shape, will it create a negative side? Because we can't have negative side measures to our shapes. So if we take negative 1/2 and we substitute that one back in, we would get negative 1/2 plus 3, or 2.5 as this side measure. Negative 1/2 substituted over here would give us 6 times negative 1/2, that's negative 3. Negative 3 plus 7 would give us 4 as our side measure there. So again, substituting this value, this negative 1/2, gives us a positive 4. And as we mentioned before, a 2.5 over here. So those measures are completely reasonable. 4 times 2.5 does give us 10. That is certainly possible. And it most likely means our other answer is going to be the excluded value. So we want to take our negative 3 2/3 and do the same thing there. Negative 3 2/3 times 6 is actually going to give us negative 20. So negative 20 plus 7 is going to be negative 13. Negative 3 2/3 plus 3 is negative 2/3. So if you plugged that number back in over here, you're going to get two side measures, both of which are negative, both of which are impossible when we talk about shapes and how they're going to look. So we can exclude that answer from our choices. And we're left with x equals negative 1/2 being our final answer.